I need to know why moving our app to the cloud didn't automatically solve our problem.
You wouldn't let me re-architect the app to be cloud native.
Just put it in containers.
You can't solve problems by saying techie things.
Kubernetes.
If you're wondering what is the best and most cost-efficient way to run your GitLab pipelines, wonder no more. I'll just tell you. I'll tell you why Kubernetes is the best option. I'll explain Kubernetes resource and limits, and I explain how they're used. Don't worry, you will not require a PhD in Kubernetes. I'll show you how to quickly configure micro-k8s on an Ubuntu desktop and how to hook it up to your GitLab organization or to your GitLab project. Lastly, we'll run a few test pipelines. GitLab provides multiple options to run GitLab pipelines. They call them executors. Most of them aren't a good idea for a typical project. So shell executor is the simplest one to configure, but it does not have any kind of job isolation between jobs or doesn't have repetitive build environments. The SSH executor is the least supported one according to GitLab documentation, so why would anybody use that? Parallels or VirtualBox executors are useful when you have Windows machine and you need to run the Linux jobs, for example. Docker executor seems to be only useful when you have Windows jobs to run. And finally, Docker machine executor is very strange. Docker company deprecated the Docker machine, so GitLab forked the Docker machine and pledged they're going to support Docker machine forever. I understand why they did it. The reason for that is GitLab itself runs their pipelines using the Docker machine, but I don't believe this is the best option. Before we move on, let me explain Kubernetes resource and limits, and the best way to explain them is using magnets. So with the typical Docker machine setup, you would launch a VM of the same size. So I have 3 here, and each one has 2 cores and 4 gigs of RAM. And these are my containers. Look, they're all different sizes. So let's say this is the Rubocop, just runs linters. This is the unit test job, and this is the system test job. And yeah, this works, but a single job uses a single machine. So if this machine is in use to run the linter, it cannot be used for anything else. This is not ideal. You couldn't put any more containers on it. You could tweak the sizes of these machines, you could make them smaller, but then this will work perfectly for smaller jobs, but then a system spec job that requires 10 gigabytes of RAM to run won't fit on these machines. What do? You're not using the resources the most efficient way possible. On the other hand, with the Kubernetes executor, you could spin up a large machine in your cloud or just configure a physical desktop computer with 16 cores and 64 gigs of RAM or however much you need, and this is one large machine. The beautiful part about this is that your jobs are all different sizes, but you can configure your job memory requirements and CPU requirements directly in your GitLab CI configuration. So I can configure that this job requires 1 gig of RAM and 1 core to run. So I could reserve this space on this large computer using the Kubernetes resource requests and limits. And I can say, all right, this is this one little job. I'm gonna put it here. It kind of fits. And then this RSpec job requires 2 gigs of RAM or 3 gigs of RAM and 1.2 CPUs because it needs to run the Ruby process and it needs to run the Postgres. Postgres typically isn't the bottleneck in Rails specs. So you spin up a container, a pod like this, and then this job fits in it perfectly. And then finally, the system specs job requires even more. System specs requires, like I said, 10 gigabytes of RAM and 8 cores to run. So you reserve the space and you put it here. And the way the Kubernetes resource and limits work is that you request the space, but then you could also specify the limit of how much any given process can grow in size. See, this RSpec job doesn't occupy the entire space, but it's possible it'll grow, the memory consumption will grow and it'll occupy the whole thing. Same with the system specs. So as you can see, this setup is kind of like a Tetris game. It allows you to use your hardware more efficiently. And even if you have jobs that require more cores and less RAM, you could configure the Kubernetes resource and limits for an odd size, like horizontally, let's say this is RAM and vertically this is CPU. You can configure your jobs to do that, and it works. And using monitoring, you could kind of watch how much memory your entire pipeline uses how much CPUs it requires, and you can tweak the concurrency. This setup requires some experimentation, but going into it, you would already have some idea of how much memory or how much CPU any given job in your pipeline requires. So you could use monitoring tools like K9S, which I'll show you, to watch how much RAM the whole system, how the whole pipeline uses, and you could play with concurrency. You could play with concurrency or parallelism of each individual job. You could run, let's say, 8 RSpec jobs at the same time, or 18 of them, or run 2 system spec jobs, or like 4 or 7 of them. And then you could kind of see how the whole system works. The best part, if you run out of space on this single machine, you could just add another machine, either of the same size or different size, depending on what's sitting on your shelf collecting dust. This is exactly what I did. I purchased another machine with the 16 cores and another 64 gigs of RAM, and I configured these 2 machines to be the same cluster. So essentially I can treat my 2 computers as one giant machine with 32 cores and 128 gigs of RAM. With this setup, I can run even more jobs in parallel by just adding more magnets. All right, this is the easy part. Let's install MicroK8s. Let's install the GitLab Kubernetes runner, and let's run a few test pipelines. This is the freshly installed Ubuntu. This is a desktop Ubuntu Linux. There is nothing installed on it. I just simply installed the Ubuntu 23.04. I installed the software updates on it, and then I rebooted the computer. That's all I did. And I also logged into my GitLab account so I could test. We'll need a couple of things. So first of all, let's fire up the terminal, and let's make it a little bigger. A couple of things we'll need to install is, let's do install vim, because we'll probably be editing the configuration files on it. Let's install MicroK8s. MicroK8s, I'll just go to the website, microk8s.io, and I'll accept all cookies. I'll get started. Sudo snap install MicroK8s, just copy and paste the command as is. It's downloading stuff. I'll kind of arrange the browser so I could kind of click into it whenever I need to. And this is the first time I'm using the snap, that's why it's taking a little longer. All right, so now the stuff is spinning up. I could just MicroK8 status wait ready, and it tells me that I have insufficient permissions, so I'm just going to run these 2 commands. And it says, after this, reload the user groups either via a reboot or by running new group MicroK8s. Let's do new group MicroK8s, and let's run this same command again. Looks like it's MicroK8s is running. High availability node. There's no second node. There's just this node. Let's enable a few things. MicroK8s dashboard, MicroK8s DNS. We won't need any of this stuff for this experiment, but if you, in case you decide to use this cluster for something else later, then you could enable a bunch of things. Then we could start using Kubernetes. It's literally a single command install. I just installed the entire Kubernetes cluster on my desktop computer, and I could start using it immediately. I could run a kubectl get all in all namespaces, and it shows me all of the stuff that's currently running. Some stuff is still container creating, which means it's probably downloading images, and it's now done. And to run the kubectl command, by default, I'll have to run the MicroK8s kubectl all the time, but I can make it easier if I just edit my bash rc, and towards the end of it, I'll just add an alias. So let's copy an existing alias, let's name it K, and let's define it as MicroK8s kubectl. If I save it and then open a new tab, now I can run K get pods, and in the default namespace there's nothing running currently, which is what I was expecting. So the next important part, in order to install the Helm charts, we'll need to get the MicroK8s config, and this is the config for my cluster. To use Helm, the config file must exist in the .kube directory. So what I'm going to do, I'm going to run this command, and I'm going to pipe it to home directory .kube config, just the file name config. Then I'm going to need to install Helm, sudo snap install Helm. So that's done. Now Helm list, that gives me the list of installed packages, but nothing's currently installed. So, and also gives me a warning that the file, the kubeconfig that I just created is group readable and it's world readable. So what I'm going to do is I'm going to chmod 600 for this file and run Helm list. Now no warnings. Next step, we're going to register a runner in GitLab. In GitLab user interface, either under organization or under project, you can go to CI/CD, and under there you can create the runner. There is a little trick when you're trying to define the runner under the org level. There's currently, I believe, there's no UI for it. Unfortunately, you're going to have to use Postman or Insomnia to call the REST API to register the runner there. But I'm just going to register the runner under this project, not under the organization, but under just this project. And this runner will only run the workloads for this project. So under CI/CD, I can expand the runners. And let me delete the old runner that I used when I was testing this. And let's create the new project runner. Linux runner, and I don't need to really specify anything other than the runner description. So I'll just do team programmer, runner, and optional configuration. I really don't need to specify anything at all. And now the runner is created. And now most important thing that I need is I need this token. I will need this token to start my Kubernetes executor. So next step, let's install the Kubernetes executor using Helm. So there's a documentation, just simple Google. I'll just add the GitLab repo, didn't copy. So GitLab has been added to your repositories. Then I'm going to update it, just in case, copy and paste. Now I downloaded all the charts, and let's search the repo. And these are the versions of the GitLab runner that are available to me. So there's this chart version and then the app version. And note there's two versions, 16.5.0. The reason being is that when I was first testing this, I installed this version because this wasn't available yet. And I couldn't get this one to work because they had a bug, they had a regression, which they since fixed in the latest chart version 0.58.1 that also has the same version of the runner, but just different scripts in Kubernetes. So that part's working. Now I need to create the values file. So with Helm charts, usually you could either run them or you could just create the file with a config file with initial values or with values that will be then inserted into running resources. So let's get this values file, configuring GitLab runner using Helm chart section to create it. So first of all, I need to create my values file. And to do that, I'm going to use the default. So default configuration can always be found in the values YAML in the chart repository, so which is exactly what I'm going to do. Just going to click the default, and so this is the file. Let's download this. I'll just download this as is. It's now in my downloads directory. So if I go to downloads, here's the values file. Let's edit the values file. And that's why I need a VI. So I installed the VI so I get the nice syntax highlighting. If you look at it, it has a lot of stuff in it, but don't let yourself be intimidated. Most of the stuff you can just leave as is. There is some things that you need to change is, for example, this runner token. So this is it. So this is the value. I'm just going to uncomment it, and I'm going to go back to my GitLab, and this is my runner token. Copy and insert, paste. Okay, it's there. Let's just look at the file from top to bottom, and we'll notice a few things along the way. So look, this is one of the important settings. It's called concurrent. It's how many jobs this runner will run in parallel. Any jobs beyond 10 will be just queued up until runner is available. There's check interval. Check interval is an important option. It's how often this runner will check GitLab.com for the new jobs. And then there is a server URL. I think it's not defaulted. GitLab URL. So that's the value that we need to specify. And I made that mistake too. it needs to be HTTPS. If you're using GitLab itself and not self-hosted GitLab, it needs to be HTTPS. So let's do this. So this is gitlab.com. That's all you need. https://gitlab.com/. And really that's it. As far as I could tell, this is enough configuration to start running jobs. This is another important section in the configuration. This is the runners section. And in this runners section, you could specify the image that will be used by default to run all of your jobs. And you could use Alpine, but it's pretty bare bones. If you want to use Snap or sudo apt-get to install packages. You could use Alpine Package Manager as well, but I'm used to Ubuntu, so I'm just going to change it to Ubuntu 22.04. And 22.04 is a long-term support version, so it'll be around for a while. So I'm going to save that as well. And now that I have the values file, I can go back to my documentation. And because I'm using the Helm 3, I could just copy this command and paste it here. And obviously I will change the file name. The values file is just values.yaml. And my namespace, I'm going to run the GitLab runner in the default. So default and Helm install namespace. Okay, so that's running. And if I do k get pods, this shows me that the runner is starting up and the container is creating. What that means is it's just downloading the Docker image layers from the internet. Okay, the GitLab runner is running. Let's check the logs. Okay, logs-f. Paste another way. And look at this, running in user mode. GitLab runner run. Initiating executor providers. Builds currently 0, max builds 0. Perfect. So let's look at this at the runner. Go to runners page. And look at this, assigned project runners, team programmer runner. It's currently available. If I go there, it shows you all the parameters, the version of the application I'm using, the IP address it's connecting from, the Linux platform architecture, and everything else I need. And now let's run some test pipelines. So just go to application. And I have a pretty basic application that only has 2 files, the README and the GitLab CI YAML. If you look at it, it's pretty basic. It's just a boilerplate example of a build configuration. It has 2 stages, build and test. Build stage has 1 job that just echoes a few things to the terminal, and the test stage has 2 jobs, the unit test job and the lint test job. And it has some sleep in it, so we could observe the way it's running and not much else. And see, I'm tailing the logs here for the runner itself, but let's modify this file. I'll just edit a single file, and I'll just change 1 character in the file. I'm gonna make a change, a commit. Oops. Update GitLab config into the main branch. Now that's committed. And let's go to pipelines. Look at this. Checking for jobs received, job ID, add a job to processing list, and it's doing things. So if you go back to my GitLab, now my pipeline is running. Build job is running, and it actually just finished. Looks like compiling the code, cleaning, compile complete. If I go further, lint test job. So see, this lint test job is running in parallel with the unit test job. So I can run up to 10 jobs on my computer. And you could use the system monitor to see how the computer is using the resources. It doesn't use much because it's mostly using network at this point because my jobs are really lightweight. If I run the k-get pods, it shows me the pod of the runner itself and then the pod of the running job. And it's been running for 62 seconds. I have a few delays there, so after 62 seconds, roughly, the job is gone. And so Kubernetes, the way it works, it just creates the pods to run your jobs up to concurrent value, which is 10 at this point. I could probably run more because this machine has a lot more power. So this machine has 24 virtual CPUs and it has 67 gigabyte of RAM, which is strange. It should be 64. You could also monitor your jobs using the K9S. Okay, let's download the K9S tool from GitHub. Let's scroll down and find the AMD64 version. So K9S AMD64. It's downloading, and now there's a K9S. So let's go to Downloads, K9S. You could install this application properly on your Linux, but I just downloaded executable, which is not a Linux way, but it pulls up this. It shows you everything that's running in your Kubernetes cluster by default. And I could narrow it down to just a default namespace by pressing 1, and currently I only have 1 pod running. I could press L to look at the logs, and it's going to tail the logs for me. It shows me how much CPU and memory is currently utilized, and it even shows me how much CPU and memory. It even tells me how much CPU and memory each pod is using it. Remember Kubernetes resource and limits? So this is exactly it. So I'm going to edit my GitLab configuration to specify how much my jobs actually require to run. And to do that, I'm going to just edit this file again. You could change these settings in the Helm charts values file to specify the default, because every job, if you look at the job, it has several containers in it. It has a build container, that's main container, that's running the Ubuntu image. There's a helper container and any service container. So you can specify separately how much CPU and memory you reserve and limit for each individual item here. You could specify how much you want to give to Postgres service, how much you want to give to Redis service, and how much to the actual build service. But let me show you how you can configure that in the build service. Let's Google. And there we go. So this is how you can actually do this. And GitLab even makes it super easy. You could just copy this whole piece of text, and it specifies the CPU request and limit, and then memory request and limit for the build container. There's those limits for the helper container and for the service container. So I'm just going to copy the whole thing, and I'm going to paste this in here in this file. So if I edit the single file right above, I'm just going to paste these variables, and let's make changes here. So let's do CPU request 800M, which is 800 millicPUs, 0.8 of 1 CPU. Let's set the limit to 1500M. Memory limit or memory request 2 gigabytes, and memory limit, let's put it at 3 gigabytes. There is also ephemeral storage request and limit, which I haven't seen before. This is the first time I'm seeing this. Helper CPU limit, let's make it, let's say 500M and 300M, and I'll leave these the same roughly. And the service CPU request, let's request 200M, and let's set the CPU limit to 500M. And remember, you could override any of these variables in any of the jobs. As you run your unit tests or you run your linters, you could change the values for that particular job type, because you'll know how much resources that job requires. And that's it. So I just made some changes, and let's fix the indentation. And this is YAML. You don't want to be yelled at, because what YAML means is yelling at your computer, in case you didn't know. So let's change this. Specify Kubernetes resource requests and limits. Looks like the requests and limits are not shown because my Kubernetes cluster doesn't have the metric server. Editor Alex here. At this point, I tried to configure the Kubernetes metric server for micro-case cluster, but I spent about 5 minutes doing that, and I couldn't get it to work quite right, and I ran out of time. So instead of doing this, I'll just show you my K9S that's connected to my Decisely work cluster that is made up of 2 machines, 2 nodes. And don't mind the names, well, I'll rename them later. And these are the pods that are running, and you could see that it shows you in semi-real time how much CPU each pod uses, how much memory each pod uses, what is the percentage of the reserved CPU, and what is the percentage of CPU limit. So let's look at this job, for example. It currently uses 52% of the reserved CPU or 27% of the limit. So the limit is quite high. You could order all your pods by pressing the Shift-C or Shift-M to order everything by memory. And you could look at them like this. So this is the most CPU intensive job that's currently running, and it's the build job. It builds the Docker container. This next one is, no, that's actually the system tests. That's the system tests that are currently running. And so this is how easy it is to configure the Kubernetes executor for your GitLab instance, and you can run your jobs, you can specify the resource requests and limits, and you can use your hardware efficiently. So as soon as I got it, the idea that Kubernetes is the best option, my first brilliant idea was, let's run everything on a cloud. With the cloud, I can scale my worker nodes infinitely. And during the nighttime, when most developers are asleep, there's no builds, I can scale my cluster way down, even to the one node, and pay almost nothing for it. And when the load is really high, when all developers are pushing merge requests all the time, I can scale my cluster way up, and I can handle way my jobs. This is going to be great, right? Wrong. It didn't work that way at all. Well, it did work for a couple of months on DigitalOcean, but we had some issues. The build times were inconsistent. It takes time to spin up the new nodes. And when the droplet spins up, it starts off as a blank sheet of paper. It doesn't have anything installed on it. So the Kubernetes cluster has to install the Kubernetes kubelet engine on it, bring this into the cluster, and then it has to download all these Docker image layers to run everything it needs to run your job. So it needs to download the Postgres image, MySQL image, Redis image, needs to start all these containers, and that takes time. In my experience, it took about 2 minutes before the newly started droplet can run any tests. So you really want to use the CPU optimized nodes where you don't share your CPU processing capacity with any other tenants. So you have to get the CPU optimized nodes, and those aren't cheap. So I ended up with the 8-core droplets. At the time of this recording, the cost of the 8-core CPU optimized droplet is about $170 a month. And in this final state, that cluster was running between one node, one droplet, and 15 droplets. So the maximum possible bill would have been about $3,000 a month. In reality, we were spending about $500 to $600 a month to run our builds, because most of the activity is during the day. It's 8 hours workday roughly, and it's not that all the time that we have to keep all of the nodes running. The problem with DigitalOcean and Linode is that also their billing is hourly. So if you spin up a droplet and use it for 10 minutes and then shut it down, you're still paying for an entire hour. Another issue with the DigitalOcean or Linode, you don't really have control over how your cluster scaling works. It just works automatically. This whole thing was good, but not great. So it felt like we were paying too much for this. Our application build isn't that large. It didn't feel like it's going to cost this much. To be fair, we ran, I think, 18 RSpec jobs in parallel, plus about 10 system test jobs in parallel. And when everything was hot and loaded, it took about 10 minutes to run the build. I wasn't really happy with this. So I was looking for other options. And if you like me and you have a couple of young kids, you probably also have a desktop gaming computer sitting there somewhere collecting dust and doing absolutely nothing. So I had this epiphany. What if I try to configure Kubernetes on this spare desktop computer and see how it'll fare against DigitalOcean? That desktop computer isn't a little wimpy computer. It has the pretty beefy AMD CPU with 12 cores or 24 virtual threads. It has 64 gigabytes of RAM, which is plenty for most of our builds. So I looked at the documentation, and turns out the Canonical, the makers of Ubuntu, they also have the project that they call MicroK8s. Simple, one of the easiest way to install Kubernetes cluster. So I formatted the hard drive and I installed Ubuntu on it. Not the Ubuntu server, nothing complicated. I just installed the Ubuntu desktop, and then I installed the MicroK8s. I configured the kubectl to connect to that, and it was surprisingly very, very easy. Then I used the Kubernetes runner Helm chart to install the GitLab CI runner. It connected to the organization, and with some tweaks, it started running our builds. And I was surprised that this single desktop was able to handle all of our needs of my entire team, with developers pushing builds daily, and it was enough to run everything. So basically that spare desktop computer replaced the need for the hosted Kubernetes cluster on DigitalOcean. My next action was I shut shut down the DigitalOcean Kubernetes cluster, and I just started running all of our builds on that desktop computer. Then a couple of weeks later, I looked online, I looked at the PC parts picker, and I put together another desktop computer that's even more powerful with 16 cores and 32 threads, 64 gigs of RAM, and it turns out the cost for this machine was about $1,500. So I ended up purchasing 2 desktop computers for about $3,000, and I configured the Kubernetes cluster on both of them using micro-K8s, and then I connected them to each other. I can treat these 2 desktop computers as a single bigger machine with 64 threads and 128 gigs of RAM and a lot of storage. Now, and I finally achieved my goal. Every build, no matter the time of day that my team submits, or every merge request, takes under 10 minutes to build. I'm a professional full-stack software engineer, and this channel is a way for me to give back to the community and to share the solutions to the problems that I came across at work. Please consider subscribing to this channel and like this video, or even buy me a coffee using the link below so my wife doesn't think it's a waste of time. Have a good day.